Hello, um, my name is Prapra Owodeha-ashaka, and I'm here to present about my experience in the just concluded MSc Embedded Systems internship, where at the end the students had to design and write the code for a microwave. So I'm from Ashesi University, and I school in I'm from Nigeria, but I school in Ghana. So first of all, I'd like to appreciate MSc for giving me the opportunity, being an international student, to to take part in this program. It has been a great learning experience for me, and I'll recommend it to more people. Yeah, so for this internship, we, the goals of the internship were to introduce us to embedded systems and to embedded C programming, and also to introduce students to the use of software simulation, because sometimes getting the hardware for designing these circuits is difficult. It may be expensive, or there may be logistics barriers. So sometimes you just need to prototype an idea quickly, and you can easily use a software to simulate. So that's one of these things that this internship set out to teach us. So we started by um, learning C programming from scratch. So the instructor did not assume that we knew everything. She started from the basics: data representation, data types, conditional constructs, operators, arrays, pointers, functions. And then later on, we went into embedded C, where we noticed some little differences between the syntax there and of core C. So now into an embedded system is any combination of hardware and software that's intended to carry out specific tasks. So, for example, smart watches, uh, dashboards in our cars, and the microwave, and a microwave, which is what we're going to use in this project. So, embedded systems are divided into standalone, real-time, networked, and mobile. And the standalone are usually either they are independent or they are controlled by another system, even though they are standalone. So a microwave, for example, is standalone. It's an example of a standalone embedded system. So an embedded system should be reliable, should be cost effective, it should consume low power, it should be efficient in its processing power, and it should be efficient in memory use, because microcontrollers, microprocessors often have limited memory and limited power supply, usually 5 volts. And so whatever system is being built based on the microcontroller or microprocessor should be able to work within the constraints of the limited power available and memory available. So a microcontroller is a compact integrated circuit and designed to govern a specific operation in an embedded system. So in this project, we are using the PIC 16F microcontroller, and this microcontroller will control things such as the time, duration, the it will help the user to select mode of operation for for the microwave. And yeah, then a microprocessor is a computer processor where the data processing logic and control is included in a single integrated circuit, or a small number of ICs. So in a microprocessor, the memory and input and output components are connected externally. So a microwave, which is what we have here, which is what we're going to do is it's basically an oven and it's used to heat food to depend maybe if you bought something that has now been in the fridge for a while and now you want to eat it, but probably you don't want to use a cooker, you can just put it inside the microwave and then using electromagnetic waves, it heats the food essentially. But this is the block diagram of a typical microwave. So what we did for this product is a simple version. So we're not directly interested in things such as the magnetron and those external and the heating chamber and those external things. So for the microwave that was designed in this project, it has four modes of operation. So the micro mode is number one on the menu and it's used to cook food normally. It's just normal mode. Then the grill is similar to the micro in operation. It is preferably used for proteins like chicken, fish, and the meat. Then the convection mode. For this mode, the oven first preheats for about a few minutes. So in this case, it will be 3 minutes. Then before you can now select how much you want the thing to heat for. Then the fourth option on the menu will be start, and this is the default setting for the microwave. It runs for just 30 seconds. Yeah. So this is the architecture for the microcontroller that we're using. So it has the matrix keypad connected. It has a CLCD connected. It has LEDs. It has a buzzer. So the CLCD is the crystal character liquid crystal display, and this is where we'll be displaying the information about the operation of the microwave. So in PiximLab, the CLCD that's available is HD 44780, and there are two options for usage. So there's the 16 by 2 display and there's also the 16 by 4 display. The 16 by 4 display is what we're using for this project. So the CLCD can display all ASCII characters and it has some custom or special characters. It has two modes of communication, the 4-bit mode and the 8-bit mode. And the data input to the CLCD is the port D of the microcontroller. So the microcontroller PIC 16, it has 5 ports, port A to E. Then the matrix keypad is what we're using to input data into the microwave. So it has it is an option that's used when you want to connect multiple buttons and you have a somewhat limited number of pins to use. So through a combination of sending voltage to the rows and columns, you can control which button press is affecting the microcontroller at any certain time. Then we'll also use the fan and the buzzer. So the fan comes on when the microwave is in action, and the buzzer comes on to signify that an operation is completed. The microcontroller has 3 timers, and we're going to be using timer 2 for this project. We'll use it to control time and duration of operations in the microwave. Also make use of interrupt service routines to respond to the interrupts. So the tools used for this project are MPLAB-X IDE, and the compiler is XC8, and then the simulator is PiximLab. So now I'll go to the project. So this is the code for the project. Um, yeah, it was very hectic to put this all together. And yeah, so we had to define header files where we wrote different macros that will enable us to identify variables easier. Um, so this is our interrupt service routine file. So let me just go straight to yeah. So when the microwave comes on, so this is the home screen. So if I want the micro option, I choose micro option. Then it shows that the power is 900 watts. So to set time, first of all, let me set a very short time to demonstrate what happens when. So I choose the time using the matrix keypad and then enter using this hash key. So the buzzer makes a noise for 5 seconds. I think that one was very short, but in the grill operation will also okay. So let me go for the grill operation. Let me use 10 this time. So now enter. So I can actually pause if I click on 5. So now I've paused it, I clicked on 5. Then I can resume. And I can also increase the time if I click on 4 again. So I can increase the time again by 30 seconds with each click of the 4 button. So I can increase the time. Then if I want to cancel this operation, I just click on 6 and then it shows that the operation is cancelled. Then for the convection mode, so we first have to select what temperature we want. So the temperature ideally should not be more than 180 degrees. So let's go with 100 and let's say 150 and then enter. So it's going to preheat. As we said, I was going to preheat for 3 minutes, which is essentially 180 seconds. So after this, we then have the option to select how long we want the actual heating to. So this is it's heating itself. It's not going to hit the device yet. The food, sorry, yet. Just hitting itself, getting itself up to that temperature. And then yeah. So we're going to wait for this to conclude. And so while we wait for that, I'll just talk more about my experience and the internship. So it was quite an interesting experience. I learned a lot. So I had originally been introduced to embedded systems last semester in my school, but who were using the Arduino and most of the functions that we used were importing libraries and yeah and one thing about this project was that most of the functions, if not all, so the only things that we used maybe like the delay function. Where was it? Um, the delay function that we used once in a while. Those are the ones that were inbuilt. But for most of the functions that we used, we actually had to define them from scratch. And that was a very hectic experience. And if you look at the matrix part, yeah, so this is what I was talking about. So if there is voltage on columns or or one row is low and the other column is high. So that's how a combination of lows and highs allows you to select which pin you want. So it was a very interesting experience. I learned a lot, and I think I'm better equipped to go more into the world of embedded systems. Mm. So, so I'm waiting for the preheating to conclude. Just 30 more minutes, seconds, sorry. Yes, so now we can select how long we want the um, the operation to take place for. So I don't know, 91 minutes and 32 seconds. This is unrealistic, but just for demonstration purposes. So it's now going down little by little. And yeah, so I think that's all. So yeah, once again, I really appreciate MedSafe for the opportunity to go through this internship with them, and I learned a lot. And yeah, I think that's all. So I should now press stop. Operation cancelled, and yeah. So back to the main menu. So yeah, so the start operation, just click on start, and yeah, the demo is 30 seconds on default. Yeah, so click on stop. All right, that's all. So thank you for watching.